About our speaker, we're gonna kick off with Ainur. It's a former chemist who made the decision to switch career during the COVID-19 pandemic. With a passion for problem solving and technology, she became a self-taught web developer, focusing on a JavaScript today. She shared her knowledge and experience with JavaScript tutor, helping others and navigate the exciting world of web development. Huge applause to Ainur. Our second speaker, this is Kelechi. She's a software engineer with experience in building core front-end features, building thoughtful UI that give your customers the best UI and UX is one of her favorite things to do. And now I'm gonna stop sharing and I'm gonna pass to Ainur. Thank you so much with your patience with me today.
Thank you, Mariya, for such an introduction. I will start sharing my screen. So, our today topic is an introduction to flow control and if statement in JavaScript. So, why we need a flow control? Flow control determines the order in which code statements are executed. Why it matters? It enables decision-making in programs, vital for building dynamic interactive application. For example, reacting to user input in real time. There is an example of flow control in real life. We have a traffic light, which signals everyone when it is red light to stop, green light go, and yellow light to prepare. In JavaScript, we have the following conditional statements to control the flow of the code, which are if, else, and else if. We are going to expand more on each of them. So we will start with the if statement. Use the if statement to specify a block of JavaScript code to be executed if the condition is true. So basically you are using an if, which is a keyword the same as const, let, or function. Then in brackets, you are making a condition which should return true if you want this block of code to be executed. Then you're following with curly braces, and here the block of code to be executed if condition is true. An example, if hour less than 18, we need to print greeting, a good day. And as you can see, the result for hour equal to 15, the result will be good day. But what happens if hour will be more than 18? So for this one, we have an else statement. Use the else statement to specify a block of code to be executed if the condition is false. Usually it is following from if statement, so you cannot have else statement by itself. If this condition is false, then the block of code to be executed if condition is false will be in the else block. And if we elaborate more on our previous example, if our hour will be more than 18, the greetings will be equal to good evening. And you can see the console result here. Now, what if you want one condition to be, what if you want to check several conditions? For this, you can use else if statement to specify a new condition if the first condition is false. For example, if condition 1 is false, then the program will check the second condition in the else if block. And if it's true, it will be executed. But if this condition also false, it will false into the else block. So let's check with the example. So if, for example, we make hour less than 10, the greeting will be good morning. Else if hour is less than 20, the greeting will be good day. And if anything is not true, it will be good night. So can you in the chat write the greeting text for each hour value? I will give you a little bit of time to check. Sorry, I can see that. Oh, okay. You can write your suggestions in the chat, and then we will check the results.
It is good morning. Good night. 14 good day.
Okay, so let's move on with the answers. Oh, we see. So good morning, good night, good day. And let's see the answers. It's good morning for the 8, good night for the 21, and good day for the 14. So as you can see, you can use if, else, if, and else statement to conditionally execute the code. So you can use the same in the function returns. A function can return a value that can be used in condition. For example, we have function get rectangular area, which accepts width and height, and we check if width more than 0 and height is more than 0, then we return the multiplying of these two. But if any of this value is less than 0, we will return 0 because you cannot calculate the rectangle area if one of the numbers are negative. And as you can see for the console log, for positive numbers, it returns its multiplying, and for negative number, it returns 0. Now I want to show you the example of how you shouldn't use if-else statements. So here we have a function which is an even number, and it checks if number is even. And if you can see, this statements checking every number possible. So if number equal 1, it returns false. If number equal 2, it returns true, and so on until 6. But what happens if our number is 8? So let's check it out. So number out of range. If I use, for example, 4, you can see it returns true, but it's not an efficient code. So what we can do to make this code efficient? Let's move to the next good example of this function. So you see that now our function only takes one or like 4 lines of code. Also, it accepts any number. So what does this function do? It takes the number, and this person sign means that it's a result of what left after the division by 2. So when you divide an even number by 2, the left number will be 0. And if you divide an odd number by 2, it will be 1. So basically, this one checking if the remaining of this operation is 0, it means that the number is even and will return true. Else, the remaining is not equal to 0, which means it once. It equal to 1 will return false. And if we run this in the console, I think we didn't. Yeah. So we need to make num equal, for example, 10. You see, it's true. And if we make it, for example, 1111, it will return false. We can optimize it even more and make it like this. And it should return the same result. What it means? It means if this result of this operation will be 1, the if statement is false, and this line of code will not be executed. And then function will continue to the next line, which is return false. And usually you will see this kind of writing of the if-else block, because you can forget, for example, add an additional curly braces here, and it will break your code. So programmers prefer to write less, but make the same result. I hope everything is clear by now. And the last topic that we need to discuss is truthy and falsy values in JavaScript. In JavaScript, a truthy value is a value that is considered true when encountered in a Boolean context. And a falsy, sometimes written falsy, value is a value that is considered false when encountering in a Boolean context. So what does it mean? It means, so we have some type of values that will always return false when put in a condition. And the examples are false, null, undefined. Number 0 is always false. -0 is also false. This one makes big int. It's a specific number type in JavaScript. Not a number also return false, and an empty string. Other values will return always true, which means the true. The empty object is also true. Empty array, number, string with any value, even the string with space will be considered true. False, a string also true. Negative numbers, big numbers, float numbers, and infinity and minus infinity are all considered truthy. Why we need falsy and truthy in JavaScript? For example, the practical application would be to check if the username is not an empty string. For example, we let this username value to be empty string, and if it's not returned, for example, by our backend API, we can console log, please enter username. Or if we have an input form and username is not provided by the user, we also can alert them that they need to enter the username. But if you have an object, so sometimes you will encounter that username is an object with the name, for example, first name, last name, and you check if this object exists, it will return true, even if this object is empty. So please be careful with using this truthy and falsy, and always remember what is considered falsy and what is considered truthy. But for example, if you want to check if the object is empty, you can use object.keys .length. It will return false. It will return 0 if the object is empty. And as we know, 0 is a falsy value. And that's it. Thank you very much. And if you have any questions, please drop them in the chat and I will answer them, or we can cover everything at the end of our session.
Thank you so much, Ainur. Amazing session. I love the cat as well. If you have a questions for Ainur, please drop them in the chat. We're gonna address them on the end, and I'm gonna pass to Kelechi. Kelechi, please share the screen and you can talk off. Kelechi, do you hear us? Kelechi?
Oh yeah,
We hear you.
hi.
Yes. Yes, hi.
Hi, can you hear me? Good evening or good day, everyone. um, Thank you for having me. I'm so excited to be sharing some knowledge with you. And I'm just going to quickly go on to share my screen.
Go ahead, Kelechi. We are here for you. Thank you
Okay,
so much.
so if you can hear my screen. Yeah, can you see my screen?
Yes, currently we see your slides. Yes, thank you so much.
All right, so um, I'm just going to quickly dive in. Okay, so in today's class, I'm going to be taking three topics. The first one is type cohesion. The second one is ternaries, and the third one is timers and intervals. All right, so moving on to the first topic, type cohesion. So type cohesion in JavaScript is when the JavaScript engine automatically converts values from one data type to another when it's trying to perform an operation that requires more than two data types. So, so this usually happens because JavaScript is a dynamically typed language, unlike some other type languages like Java that does not allow you to that enforces you to declare a type. So here's a little pseudocode of JavaScript operating on the number on data type that is more than two. So here you have a string, which is two, and then you have a number. And so when JavaScript encounters a task like this, what it does is that it concatenates the the number to the string and gives an output of 22. So in the case of its sum, this is how it's going to output the result. And in the case of the subtraction, it's going to convert the string into a number and then does this subtraction. So moving on to the next slide. So there are two types of um, cohesion in JavaScript. So there is the implicit cohesion, and then there is the explicit cohesion, or you can also call it the type casting. So in the implicit cohesion, what really happens is that when JavaScript encounters a encounters values, an operation on a value that has more than one data type, it automatically converts the value from one data type to the other, just like I previously explained. So here will be a very a quick example. While in the case of explicit um, cohesion type, it's when the programmer converts the value using different data types. So you can do this with the various it converts value from one data type to another using the inbuilt JavaScript methods. So example of one of them is you have the numbers, and then you have the string method, and you have the boolean method, and it's just as simple as when you declare a variable, you call the number method, and then you wrap the value into it, just like I have shown here. So in this case, I could just do like I have my VS Code prepared. I hope you don't mind. So here is a little snippet. So let me just open up my command line. So here is like to do like an explicit type cohesion. So example, I have a number. I'll call it num, and then so let me give it a value of two, and I want to convert this number. I want to explicitly um, cohese this number to a string. I can use the built-in string method and wrap the num into it. And if I console log this, it's going to convert this number into a string. Um, so I already prepared my command line, and so here, so it converts. Hold on. So let me just quickly. I may have a little bit of an issue doing this, but just just give me a second. I want to comment everything else. out so that it's okay. So if you do console log of this is going to so okay to string is going to um convert okay this is a number converts what's the issue here convert where am I getting this to from hold on but if you do this on a number just to be sure so oh yeah this is supposed to convert number to a string. I'm not quite sure what the problem is, but so this is okay. This is a string, and to convert. Okay, so let me just quickly try with a boolean just so that I don't keep us here. So let's see if you convert. If you try to convert this to a string, it should give you a true, a truth. Yeah, so this converts the number. So this converts this string to a a boolean value which is true because numbers in JavaScript are known to have a truthy value. If this was a null or a zero or a false, it's going to convert it to a false value. So so that's that about explicit casting. So next slide. So you can also perform cohesion, type cohesion with booleans using the these operators, the and operator, the so what really happens here is that it's whenever you're trying to like do a typecasting on a value that is not a boolean, so it first converts it to a boolean before it performs an operation on it. So generally in JavaScript, values like um, empty strings, an empty string is zero, a false value, a null or undefined. It's usually they are all falsy values. And then in the case of using the type the comparison operator, so there are in JavaScript there are two comparison operators. So you have the equals operator, and then you have the street equals operator. So this first one converts, so it checks both the data type and it also checks the values. While the street equal operator, that's the one that has the three equal signs checks for sorry, I made a mistake there. So the first one only checks for the values, why the second the first type.
I think we experienced a little bit of connection issue with Kelechi. We're gonna give her a few minutes to connect. Yeah, I think we do having a little bit of connect issue. In the meantime, if anybody has a question, how comfortable you are with the JavaScript, and are you a beginner? Are you advanced? Please drop in the chat. Me personally, I'm still in a process of growing in JavaScript. Kelechi, hey, yes. Can you share the screen again? Yeah, yeah. We don't hear you, Kelechi. You are still on mute.
How about now?
Great, thank you.
All right, so moving on to cohesion with objects. So JavaScript has like a built-in to string method that it uses to cohese objects to a primitive value type when the need arises. So first of all, by default, when you try to convert a JavaScript object to a primitive type, it would call the to string method on the Java on the object, and if it returns a value, then if it returns a value, then it uses the value. But if it doesn't, then the next thing it does, it does a fallback and by calling the value of method right on the number. But if in these two cases nothing happens, then it returns the type error, right? So it's a type error. So in the case of objects, that's how JavaScript handles um, conversion of cohesion with objects. I did a little code snippet down here to show how it's really what it would look like. So here, so this is what really happens. So it calls it a string method on this by default, but it doesn't return a value. Then it goes on to call the value of method, and if it still doesn't return a value, then it throws a type error. But in general, it's not really a good practice to convert an object into a primitive data type, because objects are non-primitive data types, but you can only do that if the need arises. So moving on to the next slide. Okay, so here's just common pitfalls in type cohesion. So one of them is that using the 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 two equal comparison operator can lead to unexpected results. So it's advisable to use the strict type comparison operator to avoid unexpected behaviors, because this one would lead JavaScript to automatically convert it by itself. And of course, we wouldn't want to have situations where you're not sure what's really happening. You want to have control of the result of your execution of your code. And the second practice is to avoid yeah. So in the case of adding in JavaScript, so JavaScript will usually so adding numbers in to strings in JavaScript results to concatenation, because it automatically takes the string and assumes it's a number and then concatenates the next number, just like I had shown in just like I had here. So here, this is what if you run this, if you execute this code, it's going to return a 510 here. So let me just quickly 510. So if I run this code to see what happens, so it concatenates 5 10 to 5 and gives us a result of 510. But in the case of subtraction, what it does is that it's concatenates, sorry, not concatenates now. So it converts, so if you did a subtraction of 20 string 20 and minus 5, so it's going to convert the 20 as a number and run the subtract minus operator on it, which will give us 15. So let me just quickly run this code, and here we get 15. So it's not really, just like I said before, it results to unexpected behaviors. Unless you fully understand how it works, it's always advisable to try to avoid um, just use cases like this and use the built-in methods to so that you can have the behavior, so that you can control what the behavior is. So moving on to the next topic of today. So we have ternaries. So what are ternaries? Ternaries are shorthand forms of writing conditional statements. They're more like a concise alternative to the if-else statements. So just like my previous code speaker give examples of how to use the if-else statement, ternaries provide like a very simple and a more readable way of writing if-else statements. So here's what a pseudocode would look like. So first you have the condition, and then followed by um, this operator, and then if the condition is true, then the first one is going to run, is going to be executed. But if the condition is false, then the second one is going to be executed. So this is what the syntax looks like. If you can, here's a clearer view of what the syntax looks like. So you have the condition. So anytime the condition is true, the first um, the first statement will run, just like you have in the condition. If the condition is false, then the second one run. But if you can take a closer look, you can see how simple it looks, unlike the if statement that has like a that is it's that is let's say longer, but it looks concise, it looks simple, and so it's advisable to use the ternary operator when you're trying to write a conditional statement that is pretty simple, just for readability's sake. So here's what a little example of the ternary would look like. So here you have a value of age 18, and so you can check. So I had just created a simple variable here, can vote, and so it checks if age um, if if can vote is greater than or equal to 18. So let's call this, I think I have a mistake here. So if you console log, so this checks if age is greater than or equal to 18, then return yes. And if age is greater than or if age is not greater than or equal to 18, then it returns no. So when you console log can vote, you're going to get the result depending on what the condition is, depending on if the condition is true or false. Just as the if statement can be nested when you're trying to check for multiple conditions. So this can quickly become hard to read and maintain, especially when you're trying to check for more than three conditions. So um, in the case of complex conditional statements, it's always advisable to avoid using ternaries because it can become tedious to read, and because of how the syntax is, it's always advised to like only stick to avoid complex conditional statements, avoid ternaries when you're writing complex conditional statements. But this is what a simple nested ternary operator would look like. So you have if score is greater than or equal to 90, then return A. And then if score is also greater than, so this allows you to add like a second condition. If score is greater than or equal to 80, then return B, else return C. So moving on to the console log grade, you're going to get your results. So moving on to the next slide, we have here are just some of the common pitfalls of using ternaries. So first one is using them for complex logic. If the condition or expression is too long, consider using the if else for readability's sake. Then the other one will be over nesting. Avoid excessive nesting of ternary operators as it can make the code hard to read. And then the third one will be mixing data types. So most times or sometimes in a practical use case, I see a lot of people try to like use data, mix up data types when they're trying to write um, ternary operator. I see that happen a lot in JavaScript because, sorry, not JavaScript, React, because React has support for conditional ranging. A lot of times people try to like mix up data types. So I would always advise, or it's always advised to avoid mixing data types um, when you're trying to use the built-in ternary operator, but that's in the case of JavaScript. So make sure both expressions after the question mark operator and these are of compatible types. So if it's in a case where you have a number and a, let's say, a boolean, I see people do that a lot. It's always advisable to try to avoid that since that can cause unexpected behaviors. So moving on to the next slide. So this is just a quick summary. So you have the ternary operator is a concise alternative to using the if-else statement, and then it's best used for simple, quick decisions and conditional assignments, or it's best used for inline conditional rendering, just as in the case of GSX. For those of us who know how to use React GSX. And the third summary is to avoid using ternary operators for complex logics or long operations as they can impact readability. Okay, so the next, moving up to onto the next slide. So I'm also going to be talking about timers and intervals in JavaScript. So what are JavaScript timers and intervals? Timers are essential for handling asynchronous tasks, enabling the execution of the code after a delay or repeatedly at a fixed interval. So JavaScript generally is synchronous in nature, but there are some situations where we want to introduce asynchronous tasks. We can use, or one of the things that we can introduce is using the timers and intervals, because what it does is that it helps us to have control over when our code should be executed, when a function or when our function should be executed. So the functions or so this functionality can be managed using the set timeout or the set intervals. So these functionalities can also it's also have or can should also be used alongside their counterparts like the clear timeout method and the clear intervals method. So these are all built-in methods that comes with JavaScript. So it's made available to you when depending on the use case, right? So while the set timeout will allow you to run a particular task um, with a specific, but allow you to run a particular task by specifying the a delay. Set interval allows you to repeatedly run a task on a fixed set, depending on a fixed interval. So moving on to the next slide, I have the set timeout method here, and this is what it looks like. So first, it has, well, I saved it in a variable here, but this is what it looks like. Then inside the set timeout takes in three parameters. The first one is the callback. That is the function, or that is the callback is the function that is going to be called. And then the second parameter is a delay. Here, the delay here is the number of time, usually passed in milliseconds, that it will take for your code to run. And then the third parameters, you have these ones are actually optional, but usually passed to the callback. So moving on to the so there are additional arguments to pass to the callback. So this is what the syntax will look like. So you have the set timeout. Again, is inbuilt into the JavaScript, so you don't have to write yours by yourself. But what's happening here is that it takes a callback. We all already know what a callback is, but if you don't know what a callback is, a callback is a function that is passed into a higher order function. And here in my snippet here, you have the sorry. So what it just does is that it's just a simple callback that just console logs executed after 2 seconds. So what happens here is that when you run this code, the the callback function, which is the part that I've just highlighted, is going to call after 2000 milliseconds, which is approximately 2 seconds. So okay, I think I have the code snippets on my VS Code. on how it's used. So just give me a second. Okay. So here is what it looks like. So yeah, so if you pass, so when you run, if you run this code, um, this code is going to execute whatever method that has been passed or whatever callback that has been passed here within 2 seconds. In our case, it's just going to run a console log. But in a real life scenario, you can declare a function and pass whatever function. You can declare a callback function and then pass it here, and then increase the number of time depending on the use case, depending on when you want the code to run, and then you pass it here. But if I run this code right now, it's going to execute what is in console log, which is it's going to execute within 2 seconds. If you notice, there was a little 2 seconds delay before it ran, so which which gives us control of when our function should be executed. I can increase the delay to 5 seconds, and then when you run this code, you see that there's going to be like a 5 seconds delay before the code runs. So here, so it's taking some time, and yes. So here our code has executed after a 5 seconds delay. But in practice, it's so because the in practice, because it's this set timers function has sometimes it's how do I put this? So sometimes it's advisable to, or it's always advisable to always clear the timeout to avoid memory leaks. So one of the ways to do that is to you can you can call the clear can call the built-in clear timeout method, right? It's just a simple method, and then you can when you call that you pass because if you save this in a variable, this set timeout returns an ID. So what you can do is to copy the ID and then pass the ID into the clear timeout in order to avoid memory leaks. So when you do this um, and run the code, it's going to return it's going to execute the code, which is the console log, and then after 5 seconds, okay, I think I know what's happening here. Just hold on. Okay, so because we're already clear, but because of how JavaScript code executes, it's going to it executes line by line. So it's going to clear timeout after 5 seconds. It clears the timeout after 5 seconds. But in a practical real time scenario, you can control depending on when you want your set timeout, your code to be executed. You can tweak the number of delays that you pass to it. And then moving on to the next slide, you have the set interval. So the set interval, just like I had explained previously, to set interval allows you to run repetitive task according to a fixed interval, right? So here you have this is what the pseudocode looks like. It looks similar to the set timeout method. So you have it takes in a callback as well, which is the function that is going to run depending on that's going to repeatedly run depending on the fixed interval that you pass. The second parameter takes in the interval, like I said. So it's also passed in milliseconds, right? So the third parameter takes in an argument that's going to be passed to the callback. Although the third parameter is optional, it's not compulsory. And so this is what it would look like time in milliseconds between each execution, and then additional arguments to pass to the callback. And then this is what the syntax will look like. It's kind of also similar to the set timeout. but this time around it repetitively runs your code depending on the number of seconds that you pass through it. So what happens here is that when you call this again, I save this in a variable called the interval ID because it out because it returns an ID. This method returns an ID, which is advisable to pass into the clear interval method in order to clear intervals to avoid memory leaks. But when you run this code, mm, so this is what happens here. So we have in our VS Code, so we have the callback here, which is going to console log executed every 2 seconds. This is similar. So let me just change it here. Set interval just to interval every 2 seconds. So when you run this code, I'm just going to quickly comment this out so that so when you run this, so let's try running this. This is going to result into memory leaks, but I just want to show you what happens when you try to run like the set interval without the so after 2 seconds, it's going to keep running our call. It's going to keep executing our call back after every 2 seconds, right? And if you don't introduce the clear interval method, it's going to run into memory leak. So this is what's going to keep happening. It's going to keep calling. It's going to keep calling this method every 2 seconds, and this happens infinitely. So it's always advisable to call the clear interval method to to stop the execution of the set interval. So if I run this, so I'm going to just quickly stop this and run it again. And so after 2 seconds, um, again, I don't think I've saved this. So let me run. Let's see. I'm having so okay. Let me try something. Let me try like a 1 second delay and check. Right. So here's what's happening. So because JavaScript code runs line by line, it's going to stop this is going to stop the execution of this code because we're already clearing the interval. But in a real life scenario, it's always advisable to use the clear interval method to avoid memory leaks. And so moving on to the next slide. So I think here's a mistake here. There's a mistake. There's a little mistake here. Sorry about that. But okay, so the next slide is this. These are the common pitfalls of the set timeout and the set intervals. So, like I said before, always clear timers using the clear timeout or the clear interval when we no longer need to prevent memory leaks. When we no longer need it to prevent memory leaks. And then the second pitfall is nesting timeouts. There are some situations where you want to recursively execute a function. But in a case like that, um, it's always advisable to avoid it. I always try to avoid it, but if then again, if it's something that needs to be used, then by all means you can use that. But the first advice is to um, avoid recursive, um, avoid nesting set timers because it leads to delays and as each execution adds a slight overhead. Yeah, so that brings us to the end of this study group. I don't know if anyone has any questions.
Thank you, Kelechi. Thank you so much. It was a really, really good session. If you can stop sharing, I'm gonna share the screen and we can check, do we having any questions in the chat?
Sure.
Thank you.
Sure. Thank you so much for having me.
Okay, everyone, it's time for the questions. And I do want to know, do you having any questions? Post it on the chat. Our speakers are happy to respond to it. Yes. If you want to rewatch the video, it's going to be available in the next week. I just want to say thank you so much for Ainur. Thank you so much for Kelechi. And congrats to Anna and to Zakia for participating in a small challenge. If you're not connected with us on social media, please do. If you want to say a personal note, DM us, you have a questions, you want to be a volunteer or you want to present your own session, let us know. And yeah, thank you so much for joining everyone and see you soon.